question is asking about the 25 kilometer to centimeter. As we all know, we need to change from kilometer to meter and meter to centimeter. Kilometer to meter, we need to multiply with 10 to the power of 3, and meter to centimeter, we need to multiply with 10 to the power of 2. So 25 multiply with 10 to the power of 3 and multiply with 10 to the power of 2, and we got the answer is 2.5 multiply 10 to the power of 6 equals to cm. Okay. The second question, we need to find the magnitude. So to find the magnitude, we must calculate the x component and y component. So for the first force is 5 Newton, and see this 5 Newton, we need to calculate the angle. So 90 degree minus with 25, we got 65 degree. So since the Newton is upward, since the Newton is to here, so the S must be to the right and the Y must be to the upward. So is a 5 cos 65. Because cos 65 because the angle is not opposite to the S. So we must use the cos 65. So 5 cos 65, we got 2.11 Newton. And for the y component, since it's opposite between this, we must use the 5 sin 65 equal to 4.53 Newton. And for the second is force 4 Newton. This is a diagram for the 4 Newton. Since it go to here, so the y axis must be to the downward and the x axis must be to the right. So 4 cos 30 equal to 3.6 Newton. And for the y component, negative 4 sin because is go to the downward. So negative 4 sin 30 equal to negative 2.00 Newton. And for 3 Newton, for x component, see at here, must get a negative 3 cos 40 equal to negative 2.30 Newton. And for the y component, together we must use the negative 3 sin 40 equal to negative 1.36, negative 1.93 Newton. So it is for the x component and y component. And for the resultant, we must calculate the x component from 5 Newton, 4 Newton and 3 Newton. This is a 5 Newton, 4 Newton and 3 Newton. So we calculate, we got the answer is 3.27 Newton. And for the y component, to get the resultant, we must calculate all the force component. So 4.53 plus with the bracket negative 2.00 bracket plus bracket negative 1.93 bracket. So we got the answer 0.6 Newton. And for the magnitude, as we know, we must use the formula as bracket root s bracket to the power of 2 plus y bracket to the power of 2 and square root. So 3.27 to the power of 2 plus 0.6 to the power of 2 square root, we got answer is 3.27 Newton. So this. Okay, for this question is asking about object is a graph about the velocity versus time, and the first question is we determine the object distance, travel and displacement, and the distance, and for the distance we need to find the area under the graph. So for 2 seconds is half times 2 and 3. See this, and for this 2 times 3, and for this one 1/2 times with 3 and 3, and for this 1/2 times with 2 and 2, and for this 2 times 1. Why don't we put the value is -2? Because we want to find the distance. So total we got the 17.5 meter. And next question is about the displacement. So it's also the same, but we need to minus with this one, with this. So we need to put the value -2, and we got the answer 9.5 meter. And next, for B, at t equal to 0 second, object position is s equal to 2 meter. Find the object position at 2 equal to 2s for s, 7s, and 10 second. So to find the 2 second, we need to find the area under the graph, which is 1/2 times with 3 and plus with 2. Why we plus with 2? Because the from the t equal to 0, the object position is 2 meter. So we must plus with 2, and we got the answer is 5 meter. And for this 4 second is also same. We need to plus with the answer before this, and we got the answer is 11 meter. And for 7 second, one also same, 1/2 minus with 3 and 3 plus with 11, so we got a 15.5 meter. And next, for the 10 second, which is 1/2 times with -2 and 2. 10 second, 2 plus 15.5 plus -2 equal to 11.5 meter. And next, we need to find the acceleration at the following times, which is t equal to 1 second, 3 second, and 4 second, and 6 second. As we know, the formula for the acceleration is a equal to v minus with u over time. V is final velocity, u is initial velocity. So for 1 second, as we know, 1 is the 1 second, this 1 is the final velocity, and 0 is the initial velocity, and 1 is the set time, second. So we get the answer is 1 ms to the power of -2. And for 3 second and 4 second, why we got the 0? Because the velocity is inconstant, which is inconstant, which is object at a rest, or it doesn't move. Same. So for the 6 second, velocity is decreased. So need to find the two. The initial velocity is 3 and the final velocity is 1. So we got the answer 1 minus 3/2. We got the -1 ms to the power of -2. And for the sketch the acceleration, and for the next question is the sketch the acceleration versus time from t equal to 0 second to t equal to 10 second. For 7 second, we need to find it is a equal to 0 minus 3/3. This is 7 second. The initial is 3, the final is 0. Yes, the final is 0, so 0 -3 divided by 3. So we get the answer a equal to -1 ms to the power of -2. So for the 9 second, a equal to -2 minus 10 minus 0/2, we get the answer -1 ms to the power of -2. is a graph 9 seconds. So that, and for the 2 second, which is a equal to 3, a equal to 3, and the final is 3 and the initial velocity is 0. So 3 equal to 0, 3 minus 3 is 0, and divided by 2, we got the answer is 1.5 ms to the power of negative 2. So this is the graph that this is constant. So that's all. So for the fourth question is about the force graph of force versus time. So the question is about an object W mass 2 kg and velocity 10 ms to the power of negative 1. It moves in a horizontal surface. Find the velocity at 7 seconds. So this is 7 seconds. So to find the velocity, we must use the area under the graph. So P equal to 1 over 2 bracket 1 times 6, and for this 2 times with 6, and for this 1 over 2 times with 2 and 6, and plus 1 over 2 times 1 and times negative 2, and plus 1 over 2 times 1 times negative 2. So the answer we got is P equal to 19 Newton second. So to get the velocity at 7 seconds, we must use the formula, which is P equal to mv minus mu. V is a final velocity and u is initial velocity, so we just put the value. We got 19, and for the mass we got 2 v minus 2 bracket 10. So 19 equal to 2v minus 20. So we bring the 20 to here, so we got the 39 equal to 2v. So let the coefficient be single, and v equal to 19.5 ms to the power of negative 1. So the fifth question is about the force. So the question is about a sketch free body diagram. So for system 2, as we know, the tension is upward and the wave is downward. So this is the body diagram for this system. And for the next system, at here is have an object on the gradient. So the reaction force is up and the weight must be downward. So this is like this, and the force is to the right and also tension, and to the left is friction because it's on a rough surface, and friction that have been give is 0.2. Next, to find the tension, we must use the summation Fy equal to 10 equal to 0. As we know, we use the system 2. So T equal to W, and T equal to mg, and the mass is 5 kg, and the gravity is 9.81. So T equal to 5 times 9.81. So we got the answer tension equal to 49.05 Newton. And for the C, the question is about we must find the force applied F. Applied is F. So system 1, at the system 1, summation of Fy equal to 0. So since the degree at here is 45, so it must be at here also. It is also 45 degrees, same with this. So the wave is down, is weight to here, so for the y-axis it must be downward, and for the x-axis it must be to the left. So summation Fy equal to 10 is equal to 0 is R minus W cos 45. Why it cos? Because is not the opposite with the angle. So R equal to mg cos 45. So R equal to 10 because the mass is 10 and g is gravity. 9.81 bracket cos 45. So we got the answer. Reaction force is 69.37 Newton. And for the submission of Fs equal to 0 is about F plus T minus F minus W sine 45. Why is we use the W sine 45? Because it is the opposite with the angle, so and either to the left. So F equal to F plus W sine 45 minus T. So F equal to coefficient times R plus mg sine 45 and minus T. So for the coefficient 0.2 times with 69.37, we got a 13.87 plus 69.37 minus 49.05. So the force that we got is 34.19 Newton. And the last one is find the acceleration. So as we know, we must use the formula which is summation of Fs equal to ma. Because why is positive? Because it's to the because it's to the left. Because it is to the right. So same with this, must use F plus T minus F minus W sine 45 equal to ma. So 34.19 plus 49.05 minus 13.87 minus 69.37 equal to 10a. So we got the answer negative 1.18 times 10 to the power of negative 3 equal to 10a. So the a is got, and make sure to put the unit. So negative 1.18 times 10 to the power of negative 4 ms to the power of negative 2. Is from chapter 5, which is work. So based on diagram here, we got ball with 2 Newton and initial velocity is 2 ms to the power of negative 1, and the length between here to here is 7 meter, and here to here 17 meter, and here to here 5 meter. So the question is asking us to find the work, velocity at the bottom, and potential energy at the peak. So to find the work, we must use the formula, which is W equal to F times S. F is force and S is displacement. So we just put the value 2 and 7. 2 is a force and 7 is a displacement. So we got the answer 14 joule. Next, for the potential energy, we use the formula is U equal to mgh. M is mass in kg, G is gravity, which is 9.81 ms to the power of negative 2, and H is head in meter. So to find the mass of the ball, we must use this, N equal to kg ms negative 2. The force that we know is 2, and the ms to the power of negative 2, which is gravity, is 9.81 times with s. That means the mass that we want to find. So we got this 2 divided by 9.81, we got 0.2 kilogram. So for the head, we need to use the theorem Pythagoras to find this. So 17 to the power of 2 minus 5 to the power of 2 square root, and we got the answer is 16.25 meter. So we just put the value to the formula, and 0.2 for the mass, G is 9.81 and the head is 16.25. So the answer is 31.88 joule. So lastly, to find the velocity at the bottom, we must use this. Total sum of initial energy equal to total sum of initial total sum of final energy. So since the ball is movement with the velocity 2ms-1 at the bottom, so we need to put the kinetic energy to the initial energy. So K1 plus U equal to K2, and the formula is 1/2 mv square plus mgh equal to 1/2 mv to the power of 2. So the mass is 0.2 and the velocity at the first is 2 ms to the power of -1. So plus with 0.2 times 9.81 times 16.25 equal to 1/2, 0.2 times v to the power of 2. So we got this, we got 0.4, and this we got 31.88 equal to 0.1 v to the power of 2. So plus we total this answer and divided by 0.1 square root, we got the answer is 17.97 ms to the power of -1.